All right, section 3, day 2. We're going to just continue what we're doing, use some more types. Let's use composite angle identities. To find the exact value of sine of 15 degrees. Okay, so what are composite angle identities? That's what we did last time. Sine, so that means you're using either sine of A plus B or sine of A minus B. Those are those composite angle identities. And how you're going to do it is you're going to use angles you know. Use the angles you know or you have memorized, right? Like, you do know 0 degrees, but that's not going to help us, right? But 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120, 135, 150, 180, all of those are ones that you've have values memorized. So if I want sine of 15 degrees and I need to use these angles I know, there's more than one way to do it. One way would be 45 minus 30. That'll give me 15. It's not the only way. You could also do 60 minus 45. So either one of those will work. There's others too that you could use. These are just going to be the simplest. So what I'm going to say is that sine of 15 degrees, that's what I'm looking for. It's equal to sine of, I'm going to choose this one. You could also do this. You could also do the 60 minus 45. Your work will look different in between, but your final answer will be the same. All right, so using composite angle identity, sine of 15 degrees is equal to sine of 45 minus 30. And from the last lesson, we've got, it's a sine, the sine guys make a sine, cosine, same sign sandwich. So it's sine of the first times cosine of the second, same sign, and then cosine of the first times sine of the second. The sines are the bread, cosines are in the inside, and same sign. So sine, cosine, same sign sandwich. All right, so that makes this equal to sine of the first times cosine of the second. Keep the sign, it's a minus sign there. Cosine of the first times sine of the second. All right, well, we know these values. That's the whole reason why we're using it. Sine of 45 degrees is rad 2 over 2. Cosine of 30 degrees is rad 3 over 2. Keep the sign. Rad 2 over 2 is what cosine of 45 degrees is equal to, and sine of 30 degrees is 1/2. Now, how you multiply fractions is top times top and bottom times bottom. So rad 2 times rad 3, how you multiply radicals is you can actually, they're both square roots, and so you can go rad 2 times 3, so rad 6 over 2 times 2 is 4, minus rad 2 times 1 over 2 times 2. They both have the same denominator, so that would be my last step, is just to write them over the same denominator as a single fraction. All right, there's your exact value of sine of 15 degrees. All right, now they want you to use the cofunction properties to find the exact value of cosine of 75 degrees. All right, so the cofunction properties say that cosine of 90 degrees minus theta is equal to sine of theta. Yeah. So if I want cosine of 75 degrees, that's equal to cosine of 90 minus what? So 90 minus what will give me cosine of, will give me 75 degrees. And that would be, if it was a 15 right there. Yeah. Well, that's equal to sine of, using the cofunction property, cosine of 90 minus theta, cosine of 90 minus 15 is equal to sine of theta. This theta and this theta are the same angle, so that means this is equal to sine of 15 degrees. And from example 1, we just found what sine of 15 degrees is. That's rad 6 minus rad 2 all over 4, and that's from example 1. Nice. Okay, let's do some proving of identities because we love it. Let's prove the identity that sine of x plus 30 degrees plus cosine of x plus 60 degrees is equal to cosine of x. Okay. What you're going to do is use these composite angle identities on both. Remember that, we'll write it over here. So sine of a plus b makes a sine, cosine, same sign sandwich, right? Cosine of an angle plus an angle, so cosine of a plus b takes on the form cosine, cosine, sine, sine. Change the sign in the middle. So cosine of a times cosine of b. There's a plus sign here, so change the sign, and then sine of a, sine of b. All right, so starting with this guy, sine of a plus b becomes a sine of x times cosine of 30 degrees, same sign, cosine of x times sine of 30 degrees. So that's your sine, cosine, same sign sandwich. Now we have a plus sign, and then I'll do this guy, which is cosine of a plus b, and that takes on a cosine, cosine, sine, sine, change the sign in the middle. So cosine of x times cosine of 60 degrees, change the sign, and it's sine of x times sine of 60 degrees. Okay. Let's clean this up now. I don't know what sine of x is, but I do know what cosine of 30 is. So this is sine of x times cosine of 30 degrees is rad 3 over 2 plus a cosine of x times sine of 30 degrees is 1/2. You have a plus sign. Cosine of x times cosine of 60 degrees is 1/2. And then a minus sine of x times sine of 60 degrees is rad 3 over 2. Yeah. All right. Well, hopefully you see that sine of x times positive rad 3 over 2, and then a minus sine of x times rad 3 over 2. Those guys cancel. And so now I know I have the 1/2 after, but it's it's 1/2 cosine of x plus 1/2 cosine of x. So you got a half of an apple plus another half of an apple makes it a whole apple, cosine of x. And look, that's what I needed to show. Done. All right, last example. Let's prove that sine of 3x over 7 times cosine of 4x over 7 plus cosine of 3x over 7 times sine of 4x over 7 is equal to sine of x. Sorry, I ran out of room. Equal to sine of x. Okay. So here is definitely a type where, remember with these proving, you're working on one side of the equation only. You don't work on both sides. You work on one and you choose the more complicated one. And this is obvious which one is the more complicated one. Definitely the left-hand side. And for this one, look for patterns. Yeah, I see a 3x over 7 here. I see a 3x over 7 here. So those are the same angle. I see a 4x over 7 and a 4x over 7, so those guys are the same angle. So do you see I have a sine, cosine, cosine, sine? Yeah? It's a sine, cosine, same sign, sandwich. Nice. All right, so what does that mean? That means that this is equivalent to, this left-hand side is sine of the first angle and the second angle, and same sign means plus sign here, so a plus sign there. Well, isn't that nice? All right, well then 3x over 7 plus 4x over 7 is 7x over 7. And 7 divided by 7 is 1. So this is sine of x. That's what I was trying to prove. Yay! All right. Not too bad, right? Hopefully. All right. I hope you all have a fantabulous day. Bye.